nuclear energy is making a comeback. Baseload electricity for homes and businesses, or heat and steam for industry, this low-carbon source of energy can replace the fossil fuels we import from elsewhere. In Europe, we're looking at new nuclear projects, big and small, to get to net zero and stay competitive. And that includes small modular reactors, SMRs. And we have options: molten salt reactors, high temperature reactors, sodium-cooled designs, lead-cooled, and more. Each of these technologies could bring specific benefits to the end user that needs them. But are we really taking a leap of faith in new, untested technologies to solve our challenges? Actually, we've already got the knowledge. Here at Blue Capsule, we're working on a high temperature reactor that could provide process heat to decarbonise heavy industry.
HTRs, as they're known, usually operate at temperatures above 800 degrees Celsius, which is much higher than the operational temperature of traditional nuclear power plants.
And we are getting a lot of questions on it. How do you know it works? But surely Japan and China have the edge. What makes you think Europeans can build them?
We think we can, and to show you why, here's a story of the European pioneers of high temperature reactor technology.
It's 1959, and scientists in Germany have begun work on a small prototype in Jülich that could give valuable insights on the behaviour of certain nuclear fuel types at high temperatures. But it was actually the English, as part of an OECD project, who got the first European HTR underway in 1964. A 20 megawatt thermal prototype reactor called the Dragon, that produced heat to some 750 degrees Celsius. 2 years later, however, in 1966, the team in Jülich got their 13 megawatt Thermal Arbeitsgemeinschaft Versuchsreaktor, AVR, into operation. This gave scientists a wealth of information on what is known as pebble bed high temperature reactor technology. So now, instead of setting up a successor to England's Dragon project, German experts decided to follow up their successful AVR with something bigger for industrial end users, namely for the chemical and heavy industries that were so important for the German economy. The nuclear fuel behind all these pioneering projects is one that features microspheres of fissile material, like uranium, in a graphite matrix. This fuel is capable of operating at very high temperatures, like 800 to 1000 degrees Celsius, and it remains stable below extreme levels of 1800 degrees. This makes the particle fuel, or TRISO as it is called today, very unique in terms of performance and safety for achieving high temperatures needed by industries.
Now that the technology became available, at Schmürhausen in the industrial Ruhr area, scientists answered the call of a group of private companies that needed process heat. A 295 megawatt electrical reactor was born. This was the Thorium High Temperature Reactor, or THTR 300. It used a mix of thorium and uranium fuels, and, like the AVR, it was cooled by helium under pressure.
By the mid-80s, it was clear that German and American expertise in HTR technology was unrivaled. But it wasn't enough to truly kickstart a thriving HTR sector in Europe.
The Schmürhausen project was revised repeatedly, owing to changing regulatory requirements and financial constraints. What's more, in the 1970s, public skepticism of nuclear energy was becoming more prevalent, before one final blow in the wake of the 1986 Chernobyl accident in the former Soviet Union. By April 2002, with the amendment of Germany's Atomic Energy Act, a legal ban on the construction of new nuclear power plants came into force. Germany's pioneering HTR program had been swallowed up by the broader political ban on nuclear energy, and the beginning of the end for nuclear power in Europe's industrial powerhouse. But what would have happened if Germany had kept its nuclear program, and especially the ambitious HTR program? What would this mean for decarbonising our industries, for the economy? Right now in the European Union, we have a little problem. We need to reduce CO2 emissions to become a carbon neutral continent by 2050. We need to stay economically competitive. And we need to reduce imports of fossil fuels like oil and natural gas. All this in an uncertain geopolitical age. So we need all the local low-carbon energies we can get to prevent deindustrialization and the socio-economic problems that this implies. Here at Blue Capsule, we think we'll be successful because Europe has the technology and the people. Several European countries, like France, Sweden or Switzerland, were able to make their electricity sectors largely independent of fossil fuel imports following the oil shocks of the 1970s, thanks mainly to hydro and nuclear power. It worked well for electricity, so could we do the same for process heat? Germany originally wanted to deploy HTRs for its industry, but stopped. Could Germany's energy choices provide some lessons? Since Germany began to turn away from nuclear in 2002, the country has emitted some 16.8 gigatons of CO2. To put this into perspective, in that time an economy like France has emitted only 9.1 gigatons of CO2. Germany did start this century with even more burning of imported coal and gas. And beyond the CO2 emissions caused by burning brown coal and lignite, the financial aspect is striking. In this period, Germany has spent some 442 billion euros importing natural gas. It's true that big efforts to decarbonise through the uptake of wind and solar energy through Germany's Energiewende have been impressive and well-intentioned. But reductions in greenhouse gas emissions were slow with regard to public money invested, some 160 billion euros between 2013 and 2019 alone. So the big question is, what could have happened if Germany had been investing in keeping its cutting-edge high-temperature reactors alive? Had Germany kept the pace of deployment of its HTRs for process heat, like France did for the electricity sector with the Mesmer plan, it would have had the tools to become independent of fossil fuel imports, to totally decarbonise its industry with less public investment. It would have been incredible. So what now? Is it too late? We believe that it's never too late. Right now in the United States, HTRs are making a comeback, with Google, Dow Chemicals and Amazon all investing hundreds of millions in HTR technology. What if Germany's pioneering expertise in high-temperature reactors could give heavy industry all the help it needs and keep jobs in local communities? What if this true leader in nuclear science and technology returned to the fold? We believe that in Europe we have all the technology and skills to make the continent independent from fossil fuels. We believe the time has come for the return of the high-temperature reactor to Europe's energy story. Join us.